All right, so for today we're going to be talking about complex numbers and the discriminant. Pure imagination. So to start off, we're going to practice simplifying square roots. So in case you don't remember, simplifying square roots is just this. 12 is the equivalent of the square root of 4 times the square root of 3. And the square root of 4, as we all know, is 2. So the final answer would be 2 square roots of 3. 30, on the other hand, is the same as 3 times 10, which is 2 and 5. So there are no common squares that we can do, which means ultimately the square root of 30 simplified is simply the square root of 30. Let's try the square root of 72. 72, well, let's see. I know that 72 is the same as saying 9 times 8. And 8 is the same as saying 4 times 2. So let's see, the square root of 9 is 3. The square root of 4 is 2. Square root of 2, so that becomes 6 square root of 2. I could have also said 36 and 2, and the square root of 36 is 6. All right, let's try this one. Negative 4. So let's see, the square root of negative 4, well, that's square root of 4 times the square root of negative 1. 4 is the same as 2, but wait a second. Negative 1. We can't square root negative 1. I guess there's nothing we can do on this video. I guess we're done with math. So let's go to the next slide where it's going to say the end. So here we go. Ooh, that is not the end. Imaginary numbers. Okay. Imaginary numbers is basically this. The square root of negative 1 is actually a number. It's I. Because remember, you can't square a negative. Any number squared is you can't square root a negative because negative 1 squared is 1. Negative 15 squared is, well, like 225. So the point is we can't square a negative. So I is the imaginary number that if you square it becomes negative 1. So an imaginary number is defined as the square root of a negative number. We represent imaginary numbers with the letter I. And a complex number is a combination of a real number and an imaginary number. We'll see those more later. So we're going to rewrite each of these expressions using I. So we're going back to this one. Remember I said that was like the square root of 4 times the square root of negative 1, which means 2 times I. There we are. So let's try another. Square root of negative 7. Well, the square root of 7 I can't simplify, but I can say that the square root of negative 1 is I. So I square roots of 7. Okay, let's try another. Square root of 12. Well, let's see. That's the square root of 4 times the square root of 3 times the square root of negative 1. So that ends up becoming 2I square roots of 3. Oh, look, see, this is a complex number right here because we have our real number, 4, and our imaginary number, the square root of negative 10. Now, the problem is the square root of 10 cannot break down because that ends up becoming 2 and 5, neither of which are perfect squares. But I can pull out the square root of negative 1, so that becomes I square roots of 10 plus 4. But when we write them, we do not want it to be this way. The 4 jumps to the front. 4 plus I square roots of 10. Okay, let's try this one. Ooh, this one looks annoying. Let's try it though. So the square root of 50, let's see, 50 is the square root of 25 times the square root of 2 times the square root of negative 1, which means 5i square roots of 2 minus 20 over 5. So if I divide those by 5, that becomes I square roots of 2 minus 4, whereas I'm going to write it negative 4 plus I square roots of 2. And that's our final answer. Okay, let's try this one. Well, the square root of 36 is just going to be 6i. And the square root of 27, that's the square root of 9, times the square root of 3, times the square root of negative 1, which means 3i square roots of 3. So this becomes 6i plus 3i square roots of 3. All right, so now we're going to find what's called additive inverse of each complex number. The additive inverse is just where we find the opposite of each complex number. So in this case, this is just an imaginary number, but the additive inverse would just be 3i. Notice it's not 3 negative I, it's just 3i. Let's try this one. Okay, so the opposite of negative 3 is 3, and the opposite of negative 2i is positive 2i, so 3 plus 2i. All right, now we're going to simplify some expressions. So this becomes 12 plus 5i minus 2, and notice plus I. So 12 minus 2 is 10. And then we have 5i plus I, which becomes plus 6i. 10 plus 6i. Let's try this next one. We're going to first add our real numbers. 2 plus 5 is 7, minus 4 is 3. And then 3i minus I is 2i, minus 6i is minus 4i. 3 minus 4i. Oh, now we actually have to FOIL. So, first, 8 times 2 is 16. Outside, plus 56i. Inside, plus 2i. And last, plus 7i squared. But remember, I squared is negative 1, which means minus 7. So we end up getting 9 plus 58i. Now let's do this one. Remember, when we square, it's that we're multiplying it by itself. So 5 times 5 is 25. 5 times negative 2 is minus 10i. As we just said, 5 times negative 2 is minus 10i. And plus 4i squared. Remember, this becomes minus 4. So 25 minus 4 is 21, minus 20i. All right, let's write this one. The first thing I do is I change this out so it becomes negative 8 minus I plus 2 plus I. So negative 8 plus 2 is negative 6. And then negative I plus I cancels out, meaning our final answer is just negative 6. All right, now we're going to write a conjugate. Now, a conjugate is where I take a complex number and the beginning stays the same. So our first term, in this case negative 2, remains the same. But we find the opposite of its second term. So minus 4i. This is important because it's going to allow us to get rid of our i's whenever they're in the denominator. So let's try this out. So 4 plus minus I, our conjugate in this case would be 4 plus I. Now if I multiply something on the bottom, I also have to multiply it on the top, meaning times 4 plus I on top as well. So I start out with the bottom. 4 times 4 is 16. plus 4i minus 4i minus I squared, which becomes plus 1. So these cancel out, meaning our bottom is just going to be 17. Now let's do the top. 3 times 4 is 12. Plus 3i plus 8i plus 2i squared, which becomes minus 2. So this becomes 10 plus 11i over 17. Let's rewrite that a little bit easier. 10 plus 11i over 17. Let's try this one. So remember, we're wanting to get rid of the i's in the denominator, so I'm going to multiply by the conjugate, which is 2 minus 5i. So 2 times 2 is 4. The 2 in the middle will end up canceling out, so it just becomes minus 25i squared, which just becomes plus 25. So our final is going to be 29 in the denominator. Now, on the top, we're multiplying it by 2 minus 5i as well. So let's see. That becomes 2 minus 5i minus 6i, and then plus 15i squared, which becomes minus 15. Negative 13 minus 11i over 29. All right, now we're going to talk about the discriminant. This is the discriminant right here, b squared minus 4ac. Now, if this looks familiar, it's because it's part of the quadratic equation, which we're going to talk about in the next video, or the quadratic formula. The discriminant is used to help us find out how many and what types of solutions the quadratic function will have. There are 3 options. 1, if the discriminant is positive, there will be 2 real solutions. If it's 0, there's going to be 1 real solution, and if it's negative, there will only be 2 imaginary solutions. So, we're going to use the discriminant to find out the number and type of solutions for the following quadratic equations. So, first thing I have to do is ask myself, what is A, what is B, and what is C? In this case, A is 2, B is 1, C is 28. So, in this case, what I do is I say B squared minus 4ac, so that becomes 1 squared minus 4 times 2 times 28. Now, to be honest, looking at this already, I can already see that there's no way that 1 is going to be greater than this number right here, which, let's see, that's 8 times 28, so that's going to be 224. So 1 minus 224, which means negative 223, which means 2 imaginary roots. Or I should say solutions. Let's try this one. A is going to be 2, B is 7, and C is negative 15. So let's see. 7 squared minus 4 times 2 times negative 15. 7 squared is 49, and 4 times 2 is 8 times negative 15. You know what? 2 times 15 is negative 30 times negative 4. That becomes plus 120, meaning 169, meaning we will have 2 real solutions. All right, let's try one more. A is 1, B is negative 12, and C is 36. So, negative 12 squared minus 4 times 1 times 36. So let's see. That's 144 minus 4 times 36 is 144, meaning 0. So there is one real root. And there you go. That's how we do this. Thank you very much. I'll be back with another video soon.